Hello, beautiful people, and welcome. In today's video, I'm going to be talking about graphing inequalities. Now, this will include just simple inequalities and also compound inequalities. This is going to be a very short video, but I do want to show you how to graph these on a number line. Disclaimer time, if I make a mistake, I am human. Let me know where my mistake is so I can learn from it. All right, so let's start with this one here. X is greater than or equal to 1. So the first thing I want to do is I want to translate. So X is greater than or equal to 1. So when you're doing this on a number line, you want to draw out that number line and identify the number that it's giving you. So here's your number line, and it wants 1 right here. So I'm going to say 1 is here. Now, it doesn't matter where your 0 is. 0 doesn't have to be in the center. I prefer 0 not to be in the center just because it looks, it looks different. So now, which direction do we want? I have 1. We're going to put a 0 or a circle on top of 1. And we're going to identify which direction. Well, we know X is bigger than 1. So which direction has the numbers that are bigger than 1? So on my left-hand side, I have -1, -2. On my right-hand side, I have 2 and 3. I know that 2 is greater than 1, and I know that 3 is greater than 1. So we're going to go towards the right. Now, before we move on, we have to also identify if my circle is going to be closed or open. So if you have an inequality that has this line underneath it, that means or equals to, or equal to. And if you have or equal to, then your circle is going to be closed because it includes that 1. We don't skip 1. We can have 1 as a possible answer. And we found it. Before we do the compound, I'm going to go ahead and shift down. Let's do this one here. Again, translate. This time I have 3 is greater than X. I'm going to retranslate that because 3 is greater than X. That means it's the same thing as saying X is smaller than, or X is less than 3. Sometimes retranslating it multiple times helps us when we're doing our graphing on a number line. Same step. Here's our number line. Where's 3? Let's say 3 is, here. So here's 4, 5. So 3, 2, 1, 0. Looks like 0 is in the center, kind of. Again, that's okay. So first thing is you want to identify the number, which is 3. Put a circle on top of it. Now you have to choose the direction your answer could be. So 3 is greater than X, which means X is smaller than 3. So which numbers are smaller than 3? 2 is smaller than 3, 1 is smaller than 3, -2 is smaller than 3, -4 is smaller than 3. So we're doing all of these numbers to the left. Now we have to decide if we are closing that circle or opening that circle or leaving it open. I'm looking at my inequality, and in my inequality, I don't have the or equals to. I don't have this line. So if you don't have the or equals to, if you don't have that line, we're going to keep it open. Let's do one more. Actually, 2 more. Let's do 2 more. Let's translate this one more time. I have X is greater than or equal to -2. Let's identify where -2 is. Let's say -2 is here. And we want to show the circle on top of -2. And so we want X is greater than. So we know that X is bigger than or equal to -2. So we want the numbers that are bigger than -2, which are to the right. And then do we leave it open or do we close it? I hope everyone's saying we close it because of this line underneath. Anytime you have or equal to, we're going to close that circle up. And one more, we have x is less than. So x is less than or equal to 7. Oh, let me change color just to remain consistent. So x is less than or equal to 7. So how would that look like on a number line? Here's our number line. We want 7. So here's 7, 6, 5, 4, 3. And again, you don't need to have 0 on a number line because of these arrows. These arrows mean that the numbers continue in both directions. All right, so here's 7. Put a circle on top of it. X is less than, so we want some numbers smaller. So which is smaller, 10 or 3? 3 is smaller than 7, so we are going in the left direction. Are we shading in? Yes, we are, because we have this or equal to. So we're going to shade that circle in. All right, now for the compound inequalities. For compound inequalities, they work exactly the same, except we're going to be translating two things. For example, I have two statements. I have x attached to 1 and I have x attached to 4. So there's going to be two statements. Let's work with the first statement. I have 1 is less than or equal to x. That's my first statement. Then I have my second statement, which is x is less than 4. So let's read this again. I have 1 is less than or equal to x. This means right here, this one right here, means x is bigger than 1. Because we know whatever value x is, 1 is less than or equal to. And then here we have x is less than 4. Do our number line. All right, so now we have two numbers that are super important. We have 1 and 4. So here's my 0. I have 1, 2, 3, 4. Here's 1. Same step, we're going to put a circle on top of both of them. So we know whatever x value, 1 is going to be the smallest it can be, but we want x to be bigger. So what numbers are bigger than 1? Well, the numbers that are bigger than 1 are all of these numbers. So I'm going to do a number line here. Let me do this one at a time. So x is bigger than 1. So here are all of my numbers that are bigger than 1. Then we have our second statement, x is less than 4. Well, here's 4. We want x to be less than that. So here is my other number. So the overlap is what we want. The overlap is our answer. For example, do you see how this and here they overlap each other? That's going to be our answer. So the graph that we have is not our final answer. Before we continue, we need to know if we're shading or not. I see that I have a or equal to when I'm working with 1. So I need to shade in 1. I don't have an or equal to when I'm working with 4. So 4 remains open. So how does our final answer look like? Let me redo this. We're going to take whatever's overlapping and draw it one more time. So here's 1. Here's 4. 1 is shaded, 4 is open, and then the area or the numbers that overlap are these numbers here. So I'm going to connect them, and then that's your answer. So this here is your graph for the compound inequality of 1 is less than x, which is less than 4. All right, let's do another one. Here it is. -1 is less than x is less than 2. So again, very similar to the previous example. Let's do our two statements. So I have -1 is less than x. My second statement is x is less than 2. And again, this one here, -1 is less than x. This means that x is bigger than -1. So this one here, because your x is switched, this means x is bigger than 1. So let's go ahead and graph that. What two numbers are important? My number -1 is important, so I'm going to put a circle on top. And 2 is important. I'm going to put a circle there. So we want x is bigger than, that should say -1. X is bigger than -1, so we want it to be in this direction. And I know x is less than 2, so I need it in this direction. So what is overlapping? Only in this area, in this section, is it overlapping. So I'm going to erase this so I don't have to redraw my answer. So the only thing that's overlapping is between these two circles. So I'm going to just create one line. And then do I need to shade anything? Do I need to keep it open or do I need to have it closed down? Well, I'm looking here and I don't see an or equal sign on both. So there's no line underneath, so we keep them open. One more. Let's translate this. -2 less than x. Then I have x is less than -6. Now again, -2 is less than x, so that means that x is greater than -2. Same thing. All right, let's graph. What two numbers are important? -2 is important, and -6. And again, don't worry that there's no numbers to the left of this because the arrow represents all of the numbers. So it can be extended. We just, mathematicians are lazy, so we don't want to write all of the numbers because that's impossible. All right, let's do this. X is greater than -2. So we want x is greater than -2. And x is less than -6. That to me looks weird because how can x also be greater than -2 at the same time as being less than -6? So I think there is a typo here. I'm going to erase this negative so that way it can make a little bit more sense. So I'm going to erase the negative. I'm going to keep it as a +6 because how can a number be greater than -2 and also smaller than -6? There is no number that exists in that way. So this is incorrect. So I'm going to erase this. And we're going to say our second number is +6, not -6. So it worked out. 1, 2, 3, 4, 5, 6. Here's my second circle. Do I have an or equals on any of them? I do not, so I leave it open. And then I have x is less than, but also greater than -2. So this is my common area. And we're done with that problem. Now, one more problem that you're going to be, or one more type of inequality that you're going to deal with, that's a compound inequality, is an or statement. Now, an or statement is, it can be this or it can be that, okay? When you're dealing with something that looks like this, when it's combined into one statement, that means an and. So this is an and statement. All of these are an and statement. It has to be greater than 1 and less than 4. It has to be greater than, x has to be greater than 1 and x has to be less than 2. So these are and statements. Now at the bottom one, it's an or statement. So it can be less than 3 or it can be greater than 5. So how do we deal with them? Well, we deal with them just like we did our simple inequalities. We do them one at a time. So let's work with this one first. X is less than 3. So here's 0, 1, 2, 3, 4, 5. My two numbers that are important. Here's my circle. Here's my circle here. We want x to be less than 5. Again, translate. So which section is less than 5? Which section is less than 3? This is the section that is less than 3. Okay. And then what's our other statement? X is greater or equal to 5. So which numbers are bigger than 5? That is in this direction. Or equal to. So that means we shade in our circle. And they're going in the opposite directions. So whenever you have an and, you're looking for overlapping, okay? And whenever you have an or, you're looking for opposite directions. Or will always give you an opposite direction. All right, beautiful people, this wraps up this video. I hope this clarifies any misconceptions that you have on how to graph inequalities on a number line. As always, thank you so much for watching, and I will see you in my next video. Bye.